3.1 Solving Systems Using Tables and Graphs. First, what is a system of equations? It's going to be representation of two or more equations. A linear system would be when both of those two equations or more are all linear. So let's say if I had an equation y equals 2x minus 5 and y equals negative 2x plus 3. Now a solution to this system is where it would cross for both of these two numbers. So the solution to this would be negative 3, 1. And I will show you how I got that in slides to come. But basically this whole chapter is going to be dealing with systems and equations and different ways that we can solve them and how we use them. In this first lesson, we're going to show two different ways that you could solve by either a table or by graphing. So if I'm going to graph both of these two equations, the first thing I'm going to do is get y by itself. So I'm going to rewrite both of these two equations so it says y equals. So here I rewrote the two equations. Now I'm going to graph both of them. I'm going to graph the first one in red. My y-intercept is at 4, so I'm going to plot the point at positive 4. My slope is 3 over 2, so up 3 over 2. Be about right there, and I'm going to draw that line. Now when you draw your own graph, it is a lot harder to see if where the points that they cross at these two equations is accurate. If I plot this point, negative 4, because that's my B, and I'm going to go down 1 over 2 and plot that point and draw my line. And the reason I say that once you draw your graph, it's not always that accurate. Here's the points that they cross it. So I'm guessing that based on my graph, this would be 1, 2, 3, 4, 5, a negative 5, and a negative 2. Now the other way that you could do this is by using a table. Here I set up a table. Now if you didn't graph this first, I would probably choose points that were going to be like 3, 2, 1, 0. But since I see that these points are closer to the negative side, I'm going to point in negative 4, negative 5, and negative 6. And I want to see if they get the same answer out. So I rewrote the equations on top. So I'm plugging this in for x. So I plug negative 4 in here. And you do that for both equations. Because if they get the same answer, then that means that would be the solution. Now I filled in the whole table here, and if you look, when I plugged in all my numbers, 5, negative 2 doesn't actually work out by mathematically. It actually would be negative 4, negative 2, because when I plugged into both equations, negative 4 gave me the same answer out. So this solution is actually going to be negative 4, negative 2. I want you to attempt this one by yourself using either a table method or the graphing method. If you did it by graphing, it would look something like this. And if you did it by the table, it would look a little differently. However, if you check your work, if you plug this into both equations, you would get that 2, negative 1 is the solution to the system of solutions, or system of equations. Now we have some vocabulary words. Now there's 3 different options that we have when we have a system of equations. We could have a one solution that be independent and be consistent. It has at least one solution. An inconsistent would have no solutions. So an inconsistent would have parallel lines like this right here. That means that they will never ever cross. Now we can have 2 different consistent, but to tell a difference between the 2 different consistents, we have independent and dependent. Now, you could have 2 equations that are the exact same line, like this. If that's the case, it would be consistent but dependent. If they depend on one another, it's going to be the exact same. Independent means they only cross at one spot. So I'd write down these 3 graphs in your notebook with the terminology below. So this problem says without graphing. Now, I don't have to graph these 2. What I really have to do is just get the y's by itself. So if I rewrite the first equation, I would want to add the 2x over, and I would get 2x plus 6, and then divide by 4. And remember, you have to divide both terms by 4, so that would be 1/2 x plus 3/2. Now if I rewrite the second equation, I just have to divide by 8. So that would be 1/2 x minus 12/8. They're both divided by 4, so that would be 3/2. Now when you're looking at these, there's a couple of things. First, you want to see if they're the exact same equation. Well, they're not the exact same equation because this is a minus or plus and a minus. So they're not going to be dependent. Then you want to see, are the slopes the same? If the slopes are the same, that means they're going to be parallel. So these two lines are actually parallel, which means they're going to be inconsistent. They will never ever cross. Pause the video and attempt these 3 by yourself. Get the y's by itself first. So these would be the equations written with y equals. The first one, they're not the same, so then I look at the slopes, and they have the same slope, so this would be inconsistent. Second one, they're not the same, I look at the slopes, they're not the same either, so this would be independent. That means it's just going to have one solution. And the last one, I look at the equations and they're the exact same. That means they're going to be dependent. And there you have it. Chapter 3, Lesson 1 in the books. Have a great, grand, awesome evening.